Excitation-Contraction Coupling, ECC, is the process that links the electrical signal of a muscle fiber to its contraction. Initiation of muscle contraction. Nerve signal. The process starts when a nerve impulse reaches the neuromuscular junction, a special synapse between a motor neuron and a muscle fiber. Acetylcholine release. The nerve impulse causes the release of acetylcholine, a neurotransmitter, into the synaptic cleft. Muscle fiber excitation. Acetylcholine binding. Acetylcholine binds to receptors on the muscle cell membrane, sarcolemma, triggering an electrical change, depolarization. Action potential. This depolarization spreads along the sarcolemma and into the muscle fiber via T-tubules, extensions of the sarcolemma. Calcium release. Sarcoplasmic reticulum, SR. The action potential travels down the T-tubules, reaching the sarcoplasmic reticulum, a specialized organelle that stores calcium. Calcium release. The depolarization causes the SR to release calcium ions into the cytoplasm of the muscle cell. Muscle contraction. Calcium binding. The released calcium binds to troponin, a regulatory protein on the actin filaments of the muscle. Tropomyosin shift. When calcium binds to troponin, it causes a conformational change that moves tropomyosin away from the myosin binding sites on actin. Cross-bridge formation. Myosin heads, part of thick filaments, bind to these now exposed sites on actin, forming cross-bridges. Power stroke. Using ATP, myosin heads pivot and pull the actin filaments inward, shortening the muscle fiber and generating contraction. Muscle relaxation. Calcium removal. After the action potential ends, calcium ions are pumped back into the SR, reducing their concentration in the cytoplasm. Tropomyosin repositioning. As calcium levels drop, troponin and tropomyosin return to their resting positions, covering the myosin binding sites on actin. End of contraction. Without calcium, the myosin heads detach, and the muscle fiber relaxes. This cycle continues as long as the muscle fiber is stimulated by nerve impulses.